If you've ever found yourself typing the same commands over and over again in a terminal, you know it can be a little tedious. But what if I told you there's a way to package up all those commands, to automate the boring stuff, and basically give yourself a command line superpower? Well, that's exactly what we're diving into today, getting started with bash scripting.
And you know, this quote right here just hits the nail on the head. So many powerful tools start out as a simple little script somebody wrote to save themselves a few minutes. Before you know it, that quick one-off becomes something your entire team or even your entire company can't live without. It's a journey from convenience to critical, and it all starts right here.
So let's get right to the heart of it. Why would you trade typing commands, something you already know how to do, for learning how to script? It's really all about moving from being a manual laborer at the keyboard to becoming an architect of your own automated workflows. We're going to stop repeating ourselves and start building things that work for us.
And look, the benefits here are huge. This isn't just about being lazy, it's about being efficient. It's about automating those repetitive tasks so you can free up your brain to focus on the hard problems. And by making your workflows consistent and repeatable, you get rid of those awful, it worked on my machine yesterday moments. You build it once, and it runs the same way every single time.
Okay, let's demystify this whole thing. A bash script might sound complicated, but it's not. It is literally just a plain text file. That's it. You take the commands you're already typing, like ls, cd, grep, whatever, and you just write them down in a file, in order. The script is just your to-do list for the computer.
All right, enough talk. Let's actually build one. We're going to go from a completely empty file to a real working command that you can run from your terminal. I promise, it's way easier than you think. By the end of this, you'll have made your very first script.
And here are the 5 magic steps. First, you just create a file. Giving it a .sh ending is just a nice convention so everyone knows what it is. Second, you add this weird-looking line called a shebang. We'll talk about that in a second. Third, you write your commands. Now, steps 4 and 5 are absolutely critical. For security, text files aren't runnable by default, so you have to explicitly give it permission to execute. Then, and only then, can you run it.
So, what is that shebang thing? Think of it like a little note at the top of the page. It's the very first line, and it tells the operating system, hey, for all the commands that come after this line, I want you to use the bash program to run them. It's what ensures your script works predictably no matter where or how you run it. It's non-negotiable, gotta have it.
Okay, so running a fixed list of commands is pretty cool. But the real power, the game-changing part, is when you make your scripts flexible and dynamic. We're about to go from a script that does one thing to a script that can do many things, all based on the data we give it. And this comparison says it all. On the left, you've got a script that will only ever say, hello world. But look at the one on the right. It uses a variable, think of it as a little labeled box called name. By changing what's inside that name box, we can make the script say hello to anyone or anything, without ever changing the echo command itself. That's dynamic. So how do we get data into those little variable boxes? Well, you basically got 2 main ways. The first is to make your script interactive. You can use the read command, which literally pauses the script and waits for the user to type something in. Or for tools that need to be automated, you can pass in data as arguments right on the command line. The script can then grab that data using special variables, like $1 for the first argument, $2 for the second, and so on. Now we are getting to the really fun stuff. This is where we give our scripts a brain. A script that just runs commands top to bottom is a tool, but a script that can make decisions, check conditions, and repeat actions, that's a true automation powerhouse. And the absolute cornerstone of all decision-making and scripting is this, the if, then, else block. It works just like it sounds. You say, if some condition is true, then do this stuff. Else, if it's not true, do this other stuff instead. The phi at the end is just if spelled backward. It's how bash knows the block is finished. This is how your script starts making choices. Now here's a super important detail that trips up almost everyone at first. In bash, you compare numbers and text differently. For numbers, you have to use these little dash options, like EQ for equal or GT for greater than. But for strings of text, you use the symbols you're probably more used to, like the double equals sign. If you mix these up, your script will not work, so this is a big one to remember. So we can make decisions. What about doing things over and over again? For that, the for loop is your best friend. It is the workhorse of automation. You can give it a list of things, file names, server names, usernames, you name it, and it will take each item from that list, one by one, and run your block of code on it. It's incredibly powerful. All right, let's talk about leveling up.
It's one thing to write a script that works when everything goes perfectly. It's a whole other thing to write a script that is robust and reliable and doesn't fall apart when something unexpected happens. These next two habits are the pro moves that will save you a world of pain.
So I'm going to ask you a question. What do you think is the single biggest, most common reason that Bash script break? Is it some complex logic error, a typo in a command? No, it's something much, much simpler and far more common. This is it. Unquoted variables. Seriously, forgetting to put double quotes around your variables is the #1 cause of bugs and weird behavior in shell scripting. It seems so small, but it leads to so many problems.
And this example shows you exactly why. Look at the buggy version. When Bash sees $filename without quotes, it sees the space, and it splits myreport.txt into two separate words. So it tries to run the arm command on a file called my and a file called report.txt, which is not what you want. But look at the fix. By simply wrapping the variable in double quotes, you're telling Bash, hey, treat everything inside these quotes as one single thing. It's that simple. Just always quote your variables.
And the second pro habit is this, using the safety switch. You put set -e right at the top of your script, right after the shebang. What it does is simple but powerful. If any command in your script fails for any reason, the entire script stops right there. It doesn't continue on, potentially running more commands with bad data and making a small problem into a giant mess. It's a critical safety net.
So there you have it. We've gone from a simple text file to a smart, dynamic, and reliable tool that can make decisions and save you time. The only thing left to ask is, what are you gonna build? Think about your day. What's that one boring, repetitive sequence of commands you're tired of typing? That's it. That's your first script. So, what repetitive task will you automate first?